Now I bet you remember that the farthest planet from the Sun is Neptune. When European astronomers debated in 1846 how to name the newly discovered eighth planet, they agreed on the name of the Roman god of the sea. This ice giant is 4 times the size of Earth, and if our planet were the size of a 5-cent coin, Neptune would be the size of a baseball. At the same time, the ice giant is 17 times heavier. If they were to approach this icy world, it would appear blue and perhaps inviting, but this blue surface is actually a layer of swirling gas and permanent clouds. So don't get your hopes up too much, they couldn't land on this planet. Its mantle of water, ammonia, and methane ice is the closest thing Neptune has to a surface. But even down there is no solid ground for them to walk on. In any case, this distant planet is surrounded by mysteries and astronomers have not yet solved all of them. Why are the winds on Neptune so fast? Why does this world give off more heat than it receives? Why is its magnetic field offset? And what is the big dark spot? So let's try to find some answers. Neptune is about 30 times farther from the Sun than our home planet. This explains why studying this distant world is so difficult. It also means that the planet receives much less light and heat from our star. At the same time, however, Neptune radiates far more heat than it absorbs. Such temperature fluctuations could be the cause of powerful windstorms. Their speed can reach up to 1,930 kilometers per hour. Another interesting fact about Neptune's winds is that they blow westward, opposite to the planet's rotation. A study published in 2013 suggested that the winds on Neptune might occur in thin layers no more than 960 kilometers thick. This shallow depth could mean that condensing and evaporating moisture could create these extremely fast air currents. Then there is the problem of Neptune's offset magnetic field. If you were to place a magnet on the planet, it would not align with the center. Astronomers are not sure why this is so. Magnetic fields are created by moving currents, and all planets, including Earth, are said to have a sensitive material moving in their belly. But with Neptune's belly, it is a little different. Its magnetic field is inclined by 47 degrees to the planet's rotation. This means that rotation and magnetism are not naturally aligned. And don't forget the big dark spot. No, I'm not talking about the biggest storm in the solar system, which is called the Great Red Spot, and is located on Jupiter. I mean a corresponding spot on Neptune that was discovered by Voyager 2 in 1999. In 1995, the Hubble Space Telescope turned its gaze to Neptune. But disappointingly, by that time the spot had already mysteriously disappeared, and scientists have no idea how exactly it disappeared. But imagine, another dark spot was discovered on the ice giant. Astronomers have known for some time that Neptune's surface is occasionally covered with such dark spots. These bizarre discolorations have been associated with high-pressure areas that come and go over the course of several years. But no one has ever observed the formation of a dark spot until recently. Since then, astronomers have observed the birth of dark spots quite regularly. Now they have a much better idea of where and when these giant vortices might form. Despite astronomers once thinking Neptune was a boring, ethereal world, the ice giant has an active atmosphere. It is turbulent with waves of clouds and violent storms. This planet also has a ring system. Disappointingly, these rings are not distinct hula hoops orbiting Neptune like those of Saturn. The ice giant's rings are strangely lumpy and contain accumulations of material that form arches in the outer ring. Astronomers explain that these clumps are actually places where many ring particles stick together. What this means is still unclear. But what I like most about Neptune is this. Astronomers believe that deep inside the planet there may be a layer where diamond crystals rain down. The enormous pressure and high temperatures in Neptune break down methane molecules and release carbon. These carbon compounds find their molecular mates and form long chains, which are then compressed together to form beautiful crystal patterns, similar to diamonds. When these diamond formations fall through the layers of Neptune's mantle, it becomes too hot for you. That's why you evaporate, rise again, and you guess it, the cycle begins again. Now you know why it is called diamond rain. How about a little fun experiment? Let's say we were to explode Neptune. Disclaimer, please do not try this at home. The impact would hurl splashes of water, ammonia, and methane ice into space. This would be followed by remnants of the planetary mantle, liquid and glowing hot like lava. And then there would be a storm of solid rock. These would be the remnants of Neptune's solid core, which consists of iron and other metals. Okay, now let's put this pretty ice giant back together. I have another experiment for you. Let us replace the moon, yes, our good old satellite, with Neptune. The ice giant is definitely much larger than the moon. The planet would look like a bright blue hot air balloon in the sky, and we would see it not only at night but also during the day. It would appear 15 times larger than the sun. If everything else remained the same, solar eclipses would seem to last forever. Once the sun disappeared behind the limb of Neptune, our planet would be plunged into total darkness for no less than an hour and a half. And since Neptune is also much more massive than Earth, its gravitational pull is much stronger. Therefore, instead of gaining a powerful companion and protector, our Earth would end up as a satellite, exactly as Neptune's moon. It would orbit Neptune slightly further than its own largest moon, Triton, and there would be a high risk that the Earth would collide with this celestial body. The tides on our planet would become 1,000 times stronger than those caused by the moon. Neptune's gravitational pull wouldn't tear Earth apart, but it would heat up our planet, as if we needed more of that, right? Seismic activity would increase, triggering earthquakes and volcanic eruptions. Well, that sounds disturbing. So let's leave Neptune where it is now. I'm happy with the good old moon. Now we are finished with the experiments. But listen to me, beyond the orbit of Neptune lies a mysterious Kuiper belt filled with massive icy objects. The most curious thing about this space formation, however, is that scientists are unable to explain the movement pattern. The only explanation they have is that Neptune may be hiding another large planet from our view. Are you in cahoots? This hypothetical planet has already been named Planet 9, and we just have to wait and see whether its existence is confirmed or not.